Hi everyone, and welcome to the Constellation crew every Friday at 6:30 here on Facebook Live. I am with our Constellation crew members this semester. We have Greg, who's new to us. Hi, Greg.
Hello, how are you?
Greg is a new graduate student here in the Department of Physics and Astronomy. We had some grad students helping out last semester, Ricky and Alec, but they got assigned to some other really interesting projects here in the department. So they're off doing that, but we are really fortunate to have Greg with us.
Oh, stop it.
Well, so welcome, Greg. And then we have Melanie, of course. A lot of people love Melanie and are very familiar with her because she is on screen here in the background, helping really promote our crowdfunding campaign. And we're going to talk more about that in just a second. But then we also have Nicolette. Hi, Nicolette. Nicolette's been helping us out for a long time now, and we really couldn't do it without her energy. So we're so grateful to have all of our students here on camera, but we also have one student who's helping out in the chat, moderating the chat for us, answering your questions, and just interacting with you there. So if you do have any questions though for us, go ahead and put it in the chat. I'm keeping an eye on it here too. So put any answers that you have to our questions in there, and then ask any that you want to get answered for during the presentation here. Okay, so Mel, since you've been talking about it a lot, can you talk about the crowdfunding campaign just really quickly for our guests?
Yeah, so we're obviously working on this crowdfunding campaign. We put some time into setting up the website and everything, which you guys can go to learn more apart from what I tell you now. But we're working to kind of upgrade our virtual programming through the planetarium. So all of us here, plus Caleb in the chat, and sometimes Ricky, we're all working to kind of upgrade our software and our supplies and things like that. So if you are able to donate or share our page or anything like that, we would love your support.
Absolutely. And we've already raised 75% of our goal. We raised over $1,000. And just recently, over the past 2 days, we had over $800 come in from Ball State faculty and staff. Ball State faculty and staff, they give so much of their time and energy and really heart into Ball State and the students here. So we're really fortunate to be able to have their support too. All right, so let's go and explore our sky. Every Friday, we explore a different constellation. This week, we're going to explore Taurus the Bull. So we're looking at a simulation of our sky. We have the sun getting ready to set over on the western horizon here, and we have our beautiful sky here. But let's go ahead and speed up time, speed up this sunset, but then also leave Earth's surface, leave our atmosphere, the air that surrounds our planet, and go into space to see things. And while it does this, take a look at the sky, see if you can notice any stars or anything like that. So I see some stars, and if I look really closely, I can see some of them shimmer and shake a little bit in brightness. But as we leave Earth's atmosphere, we can really see a lot more. We can start to see the band of the Milky Way galaxy. And we can see the stars really stable here, not twinkling. That twinkling that you sometimes see when you look at the sky, that's caused by our atmosphere, right? Our atmosphere makes the stars appear to twinkle. They're not really doing that in real life, but you'll see that there are some stars that do change their brightness periodically out in space. We call them variable stars. We're going to start by exploring one of those variable stars that's in the constellation of Taurus the Bull. So we've highlighted Taurus the Bull here. He's got this V shape here for his face. If you use your imagination and kind of turn your head a little bit, there's his body and maybe some arms and legs. Just a reminder, a constellation is a pattern of stars that we see in the sky. We use it to map out the sky. We use them to map out the sky. And Taurus the Bull is one of them. He's got these big horns here. But it's not just the stars here that are highlighted and connected together that make up the constellation. The constellation really is this huge patch of the sky that I'm drawing out here. So that includes this little guy right here that's highlighted. looks kind of like probably a smudge on your computer screen. We're going to highlight it a little bit more. But what is this, Melanie?
This is the Pleiades.
The Pleiades. Okay, so the Pleiades is this little tiny group of stars in the sky, but you can actually see it pretty well if you know where to look. And if you remember, or if you were with us last week, we explored the constellation Orion the Hunter. And I'm going to give people a chance to try to find Orion in our simulated sky here, because it's one of the easiest constellations to find. And it really helps you find Taurus the Bull and the Pleiades star cluster. So go ahead and try to find Orion the Hunter here. And if you're looking in the right spot, you're looking below Taurus the Bull. And there it is. All right, so we have Orion the Hunter. He's got 2 stars for his shoulders, 3 stars that make up his belt, 2 stars for his feet or knees, depending on how you draw him. And to find Taurus the Bull, you can use the 3 stars in a row, connect those with an imaginary line, and go up away from the ground here on Earth, in the northern hemisphere anyway, and find the V shape here for Taurus's face. But then you can go even farther and find that little tiny cluster of stars, the Pleiades, as Melanie told us, and we'll see a lot of really cool things. So let's do that in our simulation here. All right, so again, you can use Orion's belt, connect those 3 stars with an imaginary line tonight after sunset, and they should lead you to the star cluster Pleiades. If you have a really good telescope, you should be able to get a great picture like this one here from our planetarium friend Derek in Florida. But I don't have a good telescope or a good camera to take a picture like this, so I have my planetarium people to help me out there. All right, so we're going to focus in on this star right there. Again, this is the star cluster Pleiades. We're going to learn more about that soon from Melanie, but we're going to zoom in on this star and really explore that one, because that is a variable star. Again, a variable star. Well, Crew, you tell me, what's a variable star?
Well, you said it earlier, so I'm going to assume that it's a star that changes its brightness somehow.
Absolutely. It changes its brightness periodically out in space, not because of the atmosphere distortion or anything like that. But yeah, it's a star that periodically changes its brightness. And we're going to zoom in on this star and see what might be going on that changes its brightness over time. And this star, by the way, is called Pleion. Pleion. It's one of the stars in the Pleiades star cluster.
Okay. Me being a Star Wars nerd thought you said Klingon.
That's Star Trek.
Like,
That's Star Trek.
oh, that's Star
yeah.
Trek?
You just committed like a cardinal sin there. I'm pretty sure.
But I don't watch Star Trek. I watch Big Bang Theory, and they all speak Klingon, so I assumed it was Star Wars.
Yeah, those are 2 different things. Very different things, yeah.
Now my friend in the comment section is going to roast me, but it's fine.
It's all
The
good.
roast of Nicolette.
It'll
Comedy
be great.
Central still air roasts.
All right, so what do we see here? Like, there's this little disc around it, and that's actually there out in space. This isn't like a ring around the star. This is actually material being ejected out into space from this star. And it makes it appear to change its brightness. I'm gonna stop time here for a little bit just so we can focus on it a little bit more. But that disk is again being ejected from the star because the star is rotating so fast, and all of that together make it change its brightness over time. And it does it very periodically, so they can see it go up and down and up and down in such a way that tells them, you know, something's going on. And then they got information about the star, and they inferred from that light that it's giving off that there's this disk around it. So this is just a simulation. We don't have like an actual video of this, but they have really good data, really good information that tells them that this is going on. And so you might have seen in astronomy, like there's these disks that go around things, right? And I'm going to speed up time again here. And what are some objects that have disks around them? Nicolette, you had one, like a planet, right?
Planet.
A planet that has like a disc or a ring.
Yeah, okay. I was thinking it, but I didn't want to be wrong again. Saturn.
Saturn, yeah. Okay, so Saturn has this kind of disc of material around it. It's a ring system. What else has a disc around it out in space? Black holes do. They have what we call accretion disks because they're taking in or accreting material over time. There's also stars that have disks around them that are what we call protoplanetary disks, where planets are being born. So there's this new star, it's being surrounded by this disk of gas and dust, and planets are forming there. But this is something else. This is not material that is surrounding the star, going into the star or anything like that. It's not being accreted into the star. It is actually being ejected. So it's what we call a decretion disk. And that's really interesting, and it makes the star behave in the way it does. And we know it's a variable star. So again, to find Pleion and the Pleiades star cluster, just use Orion the Hunter's belt, connect those 3 stars with that imaginary line and follow it up till you get to that little tiny cluster. Let's zoom in and see it a little bit more and hear more about it from Melanie here. Okay, so let's pause it here and just kind of get our bearings a little bit, because we're still kind of looking in the, like Orion's down at the bottom here, and we're still going up past the V shape here for Taurus's face. So past that, Pleiades is right here. So that's where we're going to zoom in and see more detail. Right, Mel?
Yep. So if you look at kind of the general shape, I think it looks kind of like a little dipper, and it's also just kind of fun to say. And you might see like 7 super bright stars, but we know there's actually way more than 7 here as we get kind of a closer look. And therefore, this is what we call a star cluster. So we've talked about this a little bit before, but this is what's known as an open star cluster. So it's a star cluster that can have up to a few thousand stars. They're usually all about the same age. You might notice they all look pretty similar in color, which is just another indication of age, usually age and size. They're usually all born from the same kind of cloud, and they're sort of bound together loosely by gravity. And this Pleiades goes by many different names. One of the main names, again, is the 7 Sisters. You might have heard that before. It's because it's named after the 7 brightest stars and their parents. So there's actually 9 of the brightest stars going into the name, sort of. But this cluster is actually the most obvious of all the clusters to the naked eye. So let's say you have perfect vision, you're in a perfect environment, no light pollution, anything like that. You might see up to 14 of them naked eye, but again, don't feel bad if you don't see 14 of them. I've never seen 14 of them. I think I've seen maybe 5 or 6. What about you guys?
Maybe 5 or 6.
Generally what you can see, yeah.
5 or 6, yeah.
Yeah, about that much too.
I'm gonna have to like go out and really try though, because I actually am kind of embarrassed that I've never really gone out and tried to count them. I'm like, oh yeah, there's 7 bright ones. Usually you can only see 6, but I don't know if I've ever really done that myself. I don't have the best eyesight either, so I'd have to bring my glasses with me, I think.
Isn't that how they used to like test people for their vision?
Yeah, different cultures used to like test like hunters to see, or kind of test to see if they would be a good hunter based on how many stars they could see in the Pleiades.
Yeah, there are some other tests too with some stars from the Big Dipper, whether or not they could see both of them. There's 2 stars in the handle of the Big Dipper that are really close together. Kind of hard to discern, but they would use the stars to really make sure people have good eyesight. But I don't know, people could just lie, right?
Right.
Just say, oh yeah, I see that many.
I'm lying to you guys right now. These aren't real glasses. I can see perfect. fine. But
You mean they'd
They're-
use a star? They'd have the letter charts now that we use.
The letter charts?
Like
Yeah,
when
you know, like the big E, and then.
Oh,
letters.
yeah. Yeah. No, I guess not.
In like 2000 BC, they didn't have those.
Why wouldn't they just do that? I don't know. I guess the sky was
Kids
just
like
too
me
interesting.
who want to be blind enough to get glasses who would fake her results, but she was really close with her eye doctor, and he would say, "Nicolette, you are perfectly fine. Don't lie to me."
But yeah, if you can't see, 14 of them, that's okay. You're welcome. You can like try with binoculars. So if you have a pair of binoculars and you go out and look, you don't actually need, a fancy telescope to see everything. You can also, that's pretty fun too. You get pictures like this.
Yeah.
But if you don't have that, that's okay. I don't either. But you can go out with a pair of binoculars and it still looks really, really cool. And the reason it looks so bright like this is because it's surrounded by reflection nebulae. And I like to think of it as
That's
like
what
in the
this
80s.
this gas, this like kind of like blurry parts are. This is gas and dust, which is what you mean by a nebulae, right?
Yeah, so it's just getting illuminated by the stars within that cluster. And I like to think of it as those little things people use to go tanning that have like the metallic surface and it's kind of like shining on them. That's what I like to think of it as. So that's kind of part of the reason why it appears so bright to us. And it was most likely formed in an environment that was really similar to the Orion Nebula that we talked about last week. But it's really, really beautiful. And if you recognize it from somewhere, you might recognize it from a certain logo. I think Caleb's can put a picture of that in the chat if you can't guess it. But if it looks familiar, that's probably because it was chosen by Subaru, which actually is like the Japanese name for this group of stars here called the Pleiades. And so if it looks familiar to you, it might be because you've seen it there. It's really beautiful, so they made a good choice.
Yeah, and the emblem for Subaru cars has gotten changed so many times over the years. So it might look more like one of the first renditions of that logo for that car company. But now it kind of looks almost nothing like it, except for like it has stars and they're grouped together. Because either the last person who designed it didn't know anything about astronomy or didn't care. So they just kind of got away from the actual original idea over time.
The thought that counts.
It is. Yeah, and Caleb put it in the chat for us. So thank you, Caleb. All right. Okay, so again, if you missed it, use Orion the Hunter to really help you find the Pleiades star cluster, which is in the constellation we're exploring this week, Taurus the Bull. You can use Orion the Hunter's belt and follow that belt of stars up away from the ground here tonight and here in Muncie after sunset to find the Pleiades star cluster. But there's more going on in Taurus the Bull. We're going to zoom in to another area of the sky. And we changed our kind of field of view a little bit. So I just want to give people a good idea of what they're looking at here. And if you're really good with your sky, you might be able to see Orion here, the Pleiades, and that V shape for Taurus's face. You might be able to make that out. It's actually really hard for me anyway to find things in pictures like these sometimes because there's just so many stars. So this isn't what you would see if you went outside and just looked up at the sky with your eyes. Our eyes cannot take in that much light to pick up color, really. We need help to do that, to see that color. So we can take what we call long exposure images of the sky and other things to be able to get more detail and just more intense light. Like this picture right here is a long exposure image. So as I was talking, I hope you found Orion, or were able to find it. Orion the Hunter is right here. There's his 2 stars for his shoulders. There's his belt right here. And then we have his feet or knees down here. So if you use his belt here, you can see that and make that out on your screen. And connect those with an imaginary line and go up or away here. We can reach Taurus the Bull's V-shaped face. And then if we continue, you can see the little tiny, what is it, Mel? The little dipper?
Yeah, the Little Dipper.
Little Dipper, or the Pleiades star cluster, or the Seven Sisters, or a few other names. All right, so we're going to zoom into the V shape here for Taurus's face. And you can also see the Pleiades here in this picture. So a real picture of the sky. We're not looking at a simulated view anymore here. And what's going on here, Nicolette? This star looks a little yellow compared to the other ones.
Yes, and it is the brightest star in Taurus the Bull, called Aldebaran. It's a very fascinating star to me because I was doing my research, and it's a K-type star. So a reminder for our viewers, there are different letters that describe our stars. So M, K, G, F, A, B, O.
I always do it in the other order. So, but yeah, I think you got them all. Yeah.
Yeah, I was going from smallest to largest instead of the traditional way.
Yeah.
Backward, which is the other way.
So we got all these letters.
Yes, I did that way because M is the smallest and K is bigger than M. But for some reason, they kept calling Aldebaran a giant star, which confuses me because the giant stars are on the opposite end of the spectrum. So I was doing some more research. They call it a giant star because it's bigger. It's a bigger version of a K star. So the sun is supposed to be bigger because it's a G star, if everyone's following me. But if you took Aldebaran and placed it exactly where the sun's supposed to be, it would barely reach the surface of Mercury, or the orbit of Mercury. So it's bigger than the sun, which fascinates me.
Okay, so this little guy right here in this picture, this is bigger than our sun. It's,
yes,
of course, farther away than our sun is, so we see it smaller in the sky. And this is the reddish star Aldebaran. And so it's reddish, which we've learned before, kind of happens when stars are starting to die. And they move off of, if we want to be really scientific, like Nicolette was kind of hinting at, when they start to die, they move off of what we call the main sequence. And so those letters, they need a little bit more, we need a little bit more information with them to really understand the details about these stars. So basically, this star, Aldebaran, is much bigger than our Earth, much bigger than our sun, and it actually would go out to the orbit of Mercury if we replaced it, our sun and our solar system with it.
But less scientific jargon and a little bit more fun and cool stuff is that the name Aldebaran comes from an Arabic term that means the follower. And there are two ways you can go about it. Some people say that Aldebaran is following the Pleiades, and some say that it's glaring at Orion the Hunter and hunting him down, which is this star also has another name other than its traditional translation. It's called the Eye of Taurus. And some people, when you dig into mythology, there's a whole different reason why it's connected to the Eye of Taurus. I just think of bulls get angry, the eyes go red. You know what I mean? But it's actually very interesting. So then people say that Aldebaran is glaring at Orion the Hunter because angry bull.
Yeah, so we have his V-shaped face here, and that reddish star is his eye, glowing red eye, either looking at Orion, which is over to the left or to the east here, or towards the Pleiades, kind of following it along there towards the west. And that makes sense because stars will appear to rise and set in the east and set in the west, most of them anyway, just like our sun does. So it would be moving in this way, but they're always kind of this distance away from each other. It's always kind of following it. That's cool. Melanie, it looks like there's a lot of stars right in here.
Yeah.
I mean, there's a lot of stars everywhere I look here, but it looks like there's, this V shape. It's more than just a V shape. There's lots of them here.
That's exactly right.
Yeah, so that's because it's another cluster. It's an open star cluster. You're going to tell us about that, right?
Yep. So it might look a little bit more open than the Pleiades looks to us, and there's a few reasons that could be. But the main idea is that it's also an open star cluster, same as the Pleiades. It can also be seen naked eye. You might have a little bit more trouble seeing it. I don't know that I've ever been able to find it. That doesn't mean that you can't. But I definitely think Pleiades is a little bit easier to find, but it's the same idea. They're actually thought of, this is Hyades, similar to Pleiades, and it's because there is a relation there. So we associate the Hyades with being the half-sisters of the Pleiades. And the reason that they were put up into the sky, I'm sure there's more mythology that Nicolette can tell us later, but they lost their brother Hyas. He passed away, and they put him up in the sky. Their constellation is associated with rain because they were all crying over the loss of their brother. But a happier note, they do also make up an asterism in the constellation of Taurus, and an asterism is just another grouping of stars that's kind of easily identifiable, or a group of objects. And the reason it's called an asterism is because it's not officially a constellation, but they're just as valid as constellations. They're just shapes we can make up in the sky. So the Hyades and the Pleiades make up two posts of a gate, and it's called the Golden Gate of the Ecliptic. And the ecliptic is just the area in the sky, the kind of line where we see the planets travel. So it kind of looks like they're kind of running around the Earth and passing through this gate of Hyades and Pleiades.
Okay, so this is Hyades here, and Pleiades is over here. And the ecliptic, where you can find the planets, kind of goes in this area, or through this area here. So it goes right between Hyades and the Pleiades. That's the first, this is the first, this week is the first time I've ever heard that, and I think that that is just a really interesting thing. The Golden Gate of, wait, what is it? I can't even remember. The Golden
Gate
of the Ecliptic.
Yeah.
Cool. And I like how, like, you have a reddish star here, and then blue stars over here. Really hot blue stars, and then a star that's less hot and about to die. I don't know. That's really cool. But there's other stuff in this area of space besides just star clusters and just stars. There's planets. We know of 8 planets in our solar system, and we know of thousands of other planets in our galaxy, and we call those exoplanets. We're going to zoom into a big cloud of gas and dust and see a new star, a star that's only about 100,000 years old, which is pretty old, but for a star that could live for billions, millions, trillions of years, that is not that old, actually. Okay, so we're zoomed into just one new baby star. It's right here. What's all this stuff around it? What do you think, crew?
Is that like the disk you talked about before?
Yeah, so there was a disk around Pleion, the variable star in the Pleiades star cluster. This disk isn't ejected material from the star, though. This is material that was formed, or that was around the star when it was forming. Leftover material, basically, that didn't make it into the star. So all this leftover material formed a disk going around it. We call it a protoplanetary disk. Protoplanetary. There's a word in there, huh? Planet, right? Mm. So in this protoplanetary disk, there are planets being formed. Where do you think the planets are being formed? The bright areas or the dark areas? Because that's really all we have to go with here. We have bright areas and dark areas.
Got a 50-50 chance.
All right. Where are the planets being formed? Bright areas or dark areas? Because, like, imagine, right? Like, when this was new, when it was, like, just happening, just started, this disk around the newly formed star, it was probably pretty uniform, right? Uniform brightness, pretty much uniform density for the most part. You'd have some variation in there. But over time, when material in this disk was condensing, collapsing in on itself, forming new things, these planets, you're going to get kind of gaps. And so the dark areas are where the planets are being formed. Yeah. So the dark areas are where the planets are being formed, right in here. Maybe even one in here. It's hard to tell how big the star is because, like, we can't see that much detail. This is so far away. It's really hard to get images of things like this. This is an amazing picture, though. It was taken back in 2014, and it really kind of revolutionized the way scientists think planets form. Because this star, it being so young and having this much detail in the disk, it told them that planets form, probably anyway, much earlier in the star's lifetime than they originally thought. So that was pretty interesting. All right, that was all kind of in this area here in the sky, a tiny little area. Here's the V shape for Taurus's face. There's Aldebaran, which we heard about from Nicolette. There's the Hyades here, kind of this area here. And then we have the Pleiades over here. So this is back to a picture, a view from your sky after sunset, looking kind of south, if you want to know where to find Taurus the Bull. And you can use Orion the Hunter, remember, to help you find Taurus and the Pleiades. He's off to the east here, or to the left here in the picture, out of view a little bit. But there's more to the constellation. Emma Boggs in the chat here says that she's Taurus's #1 fan. And so if you really like Taurus, you should know that there's more to it than just this. Let's zoom up. So there's the horns that I kind of pointed out earlier. Really, Taurus is kind of this huge area of the sky, but you see here that there's the Crab Nebula. In this circle right here, I don't know, I don't really see anything, so we must have to use a telescope or something to see it in better detail, huh? All right, so let's do that and see what's there. So in that area, it looks dark, but it's not. It's all of this. So what's going on here? I think, Greg, you're going to help us out with this one.
Yeah, so the Crab Nebula is actually a supernova remnant. So just kind of a brief review, right? So I know we talked about supernovas last week, but a supernova is basically just a supermassive star that explodes. And the Crab Nebula is actually the result of that explosion. Interestingly enough, in the picture, you didn't really see anything where the Crab Nebula was, right? But in the 11th century, there were ancient astronomers that noticed what they called a guest star that was bright enough to see during the day. So even though you don't see anything there now, back in the 11th century, it was bright enough to see at all times for a couple weeks. And that, we believe, is actually the explosion itself that gave rise to the Crab Nebula. And the Crab Nebula itself is, so once a supernova explodes, it has a couple different things it can result in, right? Maybe a neutron star, maybe a black hole. In this case, we have a neutron star. That's kind of what gives the Crab Nebula what we look at as the bluish color, right? Comes from electrons zipping around close to the speed of light, that neutron star. But a neutron star in the Crab Nebula, it's actually a pulsar. So what that means is it's spinning rapidly, right? And this pulsar at the center of the Crab Nebula actually revolves or rotates 30 times every second. So we have a full star that's rotating 30 times per second. So really fast, right?
Wow.
And surrounding that neutron star, we have a gas cloud, basically, right? So that's what the results of that supernova explosion.
Like all this colorful stuff, right?
Yep.
Yeah.
Yep.
Like the star
and
guts.
That's what we see all around it. Exactly. Yep. The star spewed its guts all out. And that's what we see, right? And as such, the Crab Nebula is actually still expanding, interestingly enough. So it's gotten larger throughout its lifetime as that, the star's guts, right? The gas cloud just expands, which I think is kind of interesting. The name of the Crab Nebula actually comes from the 19th century astronomer William Ross, who drew it, and when he drew it, he said it looked like a crab. So they just went with the Crab Nebula.
Yeah, I don't. Maybe it did back then with that telescope, but here I don't really see a crab.
I think you have to like tilt your head like just a little bit because it's elongated, right?
No. No.
You can see like little pinchers.
A king crab.
What, Nicolette?
I can kind of see a king crab. Like there's an outer circle, or there's like a circle in the middle, and then there's an elongated shape.
Yeah.
So the circle in the middle is the base, and then the elongated shape going in front of it is one of its claws. And then there's another elongated shape on the other side. I sort of see it.
I only know my crabs like Mr. Krabs from SpongeBob.
There you go.
I don't see that.
I mean, we
I
can
don't
always
think
just
he
chalk
had
it
that
up
back
to.
then.
That's true. We can always just chalk it up to William Ross being a really bad artist, I guess.
I think there was a few variables. I don't know. I'll give him credit. It probably looked like a crab when he was looking at it.
Yeah.
Okay.
Hard to draw.
Yeah. But yeah, this is what you would see if you had a really good telescope, a really good camera. You can take in light, lots of light, and start to get this detail, this color. This is a picture taken in what we call visible light that we could actually see with our eyes. So if we were up close next to this nebula in space, we might be able to see, all of this with our eyes. But usually there's other light that's coming from objects out in space that we can't see. And we have another picture of the Crab Nebula that really highlights that. And usually when you are looking at an image, an astronomical image, and there's pieces of it that are coming from, visible light, or what we can imagine as visible light, or see as visible light. And then other types of light too, included in that picture is what we call a composite image. So basically what you're seeing here is more than what our eyes can see. You're seeing many different wavelengths of light. Okay. Again, it's a composite image, so it looks a little different. Like you see some purples and stuff that you didn't see in the last one. You can see some more detail.
You can kind of see the neutron star in the middle of this one too.
Yeah, so let's break it apart. So there's radio light. Here's infrared light. Here's optical, or the visible light, just color-coded in a weird way. Ultraviolet light. And then here's where you can really see that neutron star and the pulsar in X-ray light. I'm going to pause it here. So yeah, that ball right there, that's the neutron star, right? Or light, X-ray light coming from it. So you can really see that detail. And there's like a disk around it too. And these are jets coming from it as it kind of pulsates.
Yeah. Interestingly enough, the term crab is actually used in high energy astrophysics as a unit. So whenever you are reading, you find yourself reading high energy astrophysics, a lot of times they'll refer to like a lot of high energy stuff in terms of the units of crabs. So like, something might be 1.5 crab units or whatever. So to describe the energy. Really interesting.
Yeah. Terry in the chat says that he's noticed through astrophotography that the crab changes over time. Yeah. Do you remember how fast these are going out? Like the material is kind of going out into space. It's super fast, right? Like
yeah, I don't remember what it was.
Probably thousands of miles a second, if not even more. So just incredibly fast. I mean, there's even material that's going faster than the speed of light, you said, right? Or not faster than the speed of, excuse me, very close. I'm sorry. Yes. Yeah. Because nothing can go faster than the speed of light. What's wrong with me?
Yeah.
Yeah, very close to the speed of light there.
Yep. And I would assume that gas is going some fraction of the speed of light as well.
Yeah. So this is just growing and evolving over time. So yeah, maybe it did look more like a crab at one point.
When it was a little bit more condensed, yeah.
Yeah.
Is it expanding from that initial explosion still?
Yeah. Yeah.
Yep.
Supernova events are the most energetic thing that we've ever explored. We learned last time that if you're 50 light years away, and remember a light year is 6 trillion miles, so 6 times 50 trillion miles. No, 50 times 6 trillion miles. If you were within that distance, you would get affected by a supernova explosion, and that's still really far. So it's a good thing that the Crab Nebula is how many light years?
65. It's like 6,500 light years away.
It's pretty far. Okay,
it's pretty far. Yeah,
we're clear. I just think that's wild.
Yeah,
You could still see it from here too.
Yeah, and that's again, and I'm actually really happy we went back to this picture because, like I said, in the picture you can't really see anything, but in the 11th century for a couple weeks, I mean, it was the next brightest thing in the sky after the sun and the moon. So.
Yeah.
And that tells you, I mean, really how energetic the supernova explosion had to be 6,500 light years away and outshine everything other than the closest star to us, and then obviously the moon as well. So.
Yeah. It's wild. Dan Malone, who's a great supporter of the Constellation crew, he said that the Crab Nebula is getting harder to see in backyard telescopes all the time due to the expansion. So as it expands, of course, it's not going to be as luminous as maybe it once was, and makes it difficult. But I don't know, I think that's kind of cool.
Yeah.
There has to be a new one. Maybe Betelgeuse, that red star in Orion that we explored last week, will go supernova sooner rather than later, but probably not. All right, so what's this little graphic, Nicolette?
This is an interesting picture.
Yeah.
But I kind of like it. Before I dive too deep into this, I wanted to touch on something really fast. Throughout the entire show, we've been talking a lot about mythology and how each picture, like one here, connects somehow into mythology, whether it's Greek, Hindu, ancient Egypt, it doesn't matter. It connects into mythology in some way. But in this case with Taurus, it's a little bit different. There's a lot of cultures that depict Taurus a little bit differently and give it different names. But we're mainly going to be looking more at history and how Taurus can be traced back very far into histories. Therefore, this is going to be more of a history lesson and rather than a mythology. But for those who look forward to that, I'll give you some really fast.
Because if people don't know, Nicolette is usually the one who talks about mythology at the very end of all of our shows. Sorry, Nicolette, go on.
It's okay. So yes, this is a bull. So Greek mythology is the main one that we usually turn to, and in this case, kind of funny, Zeus falls in love with a princess named Europa. Bonus points to our viewers who can tell me how that name relates to something in our solar system. Comment below. So he falls in love with her, and to impress her, he turns himself into a bull, and basically they ride off together to an island named Crete. Crete? Yes.
The island of Crete.
Very brief.
Where the Minotaur is.
Yeah. Yes. Yep. So, very brief Greek mythology. That's all we really can get there. Apparently, Zeus turns into a lot of different things. But I think it's kind of funny. However, if you dig more into Taurus's history, it can actually be traced back all the way to the Stone or Bronze Age, which is thousands upon thousands of years ago. In fact, some people depict Taurus in this cave in France called the Lascaux Caves. Yes, Lascaux Caves. You'll see a picture of it in a minute here. So this was discovered by 4 teenage boys. They were wandering around in their home area in France, in southeastern France, and their dog fell down a hole. And of course, dog lover here, you want to protect your dog. So one of the boys goes down the hole to go get him, and they discovered this vast cave system. For me, when I think of cave, I think of a tiny little thing that you kind of live in for a little bit in the side of a mountain, but apparently it's a vast system full of all different kinds of pictures. So here you can see in the picture that there are dots on the bull's face. So many people have said that there's bulls down there and one of them has dots on his face, and that is supposed to be the Pleiades.
I think they say this is supposed to be that V shape there for the bull's face, like Taurus's face. This little cluster of dots here, I think some people see that or think that is supposed to represent the Pleiades star cluster.
Oh, I must have read it somewhere else differently. The hard part about this is that the Lascaux caves are very important to history. They're 17,000 years old, they estimate. But because of that, it's really hard to definitely prove that something is going on. So in this case, I read that on the face, that's Pleiades, the dots. But Dana said that it's different, which is totally fine because we can't exactly prove, yes, that's the way to go. But I will admit that Dana's way makes way more sense.
That's just what the articles I've read said, and you know, I guess it kind of makes sense because then the dots that were over to the left of the bull might be Orion with his belt, and you can kind of piece it together that we have the V shape for Taurus's face, you have Pleiades up here, so it kind of goes in this order here. Going back
They'd
to
be very poor hunters. They could only see 6 stars in the Pleiades.
Yeah. Yeah, okay, so going back here. Well, remember, one of those 7 stars in the Pleiades is a variable star, so sometimes it's so dim you can't really see it. So, like, 6 is okay. But yeah, going back to this original, representation here, we have maybe I don't know, it just kind of looks like a bunch of dots here.
Yeah.
And then here. But there's a bunch of dots over here, too. But they think that maybe this is representing Orion's belt, the V shape for Taurus's face, and then the Pleiades star cluster as really shown in the next graphic here.
Yes.
But it's so old, right? Nicolette, you said it was what, 17,000 years old?
Yeah, and that's even just an estimate since I know no one who is 17,000 years old. So, but that's what archaeologists say, that this cave is extremely old and is actually open to the public, surprisingly.
Really? Then why aren't there more pictures of this? It's really hard to find these pictures. We should go and get some really nice high-res pictures.
Like I said, field trip.
Yeah.
It could be that there are certain museums that do not allow pictures because the flash that you have when you take pictures diminishes the color of the painting over time.
Mm.
So they might be very paranoid about that.
So how is it lit? How is this area lit so people can go in it and get tours? Do they have special lighting that makes it so it doesn't degrade?
I am not there.
Nicolette, no. You don't work there?
I saw it briefly in an article that a few years after it was discovered, it was open to the public.
I wonder if it's still open. They might have closed it, for various reasons. Dan Malone, by the way, did get your Europa question. So Dan said it's a moon of Jupiter. So Europa is one of the 4 what we call Galilean moons of Jupiter, or one of the 4 really large ones. So Europa's in our solar system as a moon, as well as kind of included in the mythology that we heard about from Nicolette. And then he also said that the movie 2010 A Space Odyssey, spelling question mark, 2001 A Space Odyssey, I think he meant, is I guess there's another reference. I've actually never seen that movie. Have you guys seen 2001 Space Odyssey? Yeah.
Nope.
It was on like all the time when I was growing up in the background, and it just always sounded like weird noises, and I'm like, what is this? I don't get it. But apparently it's in that movie too. I think it's also a movie, Europa, right? With the one actor from ER. I don't remember. You guys are too young anyway. Some of you anyway.
You're apparently asking the wrong group.
I am, yeah. All right. So, Nicolette, did you have anything more to say about the drawing there? It kind of went by fast, huh? So this is what people kind of imagine it as: Orion, Taurus, and the Pleiades. Again, here's a cave picture where these dots here might be Orion's belt. These dots might be the V shape for Taurus's face, and then here's the Pleiades up here. But nice bulls. This is good artwork. I like it.
Yeah, beautiful. It's Very beautiful.
17,000 years old too. Wow. Okay, back to our view of the sky. Just to wrap things up here, we do have Taurus the Bull that you can check out tonight after sunset in the southern sky. Use Orion the Hunter to help you find it. Remember, just follow his belt stars up to the V shape here, which you can see in this graphic or this picture here. And then if you go even farther, you should see the Little Dipper or the Pleiades star cluster or the Seven Sisters or Subaru, whatever you want to call it. Go check it out. It's really cool to look at, especially with a pair of binoculars. All this area here, there's so much going on. Maybe you won't be able to see the Crab Nebula with binoculars, but you could try to catch it with a backyard telescope. All right, friends, any final thoughts here on our constellation before we give people another reminder about our crowdfunding?
Talked about a lot.
We did. We covered so much. We try to keep it, you know, accessible to any age here with the Constellation crew. But, you know, remember that these are students in the Department of Physics and Astronomy. They're learning about physics and astronomy and college level classes all the time. Kind of gets to you a little bit. So you want to bring all your knowledge that you've learned in class, like O stars and G stars and K stars and main sequence and all that stuff. But hopefully you got some really cool tips to find these things in your sky. Apparently there's clouds in Muncie as usual, Terry said in the chat. So unfortunately, you might not be able to see it tonight, but good thing it's going to be in the sky for a little while longer. So go out the next clear night. And then Belle Wines said, great show, everyone. I know we know and really appreciate Belle. So thank you, everyone, for watching. If you want to help out with our crowdfunding campaign, we would really appreciate it. We know that these are hard times, and really, though, any amount you can give, $5, even less than that, would really help us out here. So I put a link to that in the chat if you're able to, or if you just want to learn more about what we're doing here with our virtual experiences at Ball State. So check it out. Until next week, do you remember, crew, what we're exploring next week?
I don't remember.
No, it's another constellation, right? It's the constellation Auriga. I don't talk about Auriga much, so we're going to be learning a lot together about that one. Well, take care, everyone. Have a great weekend and stay safe.